Hi, sixth graders, welcome back. Remember I told you yesterday we were going to start out with this problem. It said that 3 people went to a cafe on the weekend. They shared, their bill came to $25. Each student gave the server $10 bill. The server took this $30 and brought back 5 ones. Okay, each student took $1 back, leaving the rest for the tip, $2. As she walked away from the cafe, Lynn thought, wait, that doesn't make sense. Since I put in $10 and got back $1, I would end up paying $9. So did Mai and Priya. Together, we paid $27 and we left a $2 tip. That makes $29. The waiter originally got $30. Where did our extra dollar go? All right, so if you think about this program or this problem and you think about it, it does look like there's a missing dollar. But what I want you to do is go back and think. She's saying that, okay, we each paid $9 for lunch, right? So if they gave the server 10 and they each got $1 back. So that means each person paid $9. Which would equal $27, right? Because 3 people times $9 is $27. Here's where the trick of the problem comes in. So they each paid $27. The bill wasn't $30. The bill was $25. Okay, so if each person paid $9, that's a total cost of $27. The bill was $25. When you subtract those two, you get the $2 tip. Okay, so it's kind of a trick problem. You just have to really think through it. Does that make sense? Those are kind of fun to do every once in a while. All right, well, that was yesterday's. So here, we're going to be talking about absolute value. This is not going to be a long lesson, I don't think, because it shouldn't take us that long. All right, so what it's asking you to do is, in your head, decide what's closer to 0, 9/11ths or 15/11ths, less than 1, greater than 1. So this would be closer to 0 because it's less than 1, right? And on a number line, I'm just gonna draw one number line, okay? If this was 0, let's say this is 1, and this is 2, okay? This is -1. All right, if I look at 9/11ths, 11/11ths would be 1, 9/11ths would go about right here. 15/11ths is more than 1, okay? So 15/11ths is really 1 and 4/11ths, about here, so definitely this one was closer. If I think about 1/5 or 1/9, okay? If you think 1 out of 5, which is a bigger piece of a pie, if you got 1 slice out of 5, I'm just gonna draw a little bit different picture. I don't know if I can do 5 equal pieces, but you get the idea. Well, that's only 4. So if you got 1 out of 5, or if I got 1 out of 9, 1, 2, 3, 4, 5, 6, 7, 8. We're gonna stick another guy in there, 9, okay? Which one would be closer to 0? The 1 out of 9, because it's way smaller than 1 out of 5. Not that my pies are the best, but you get the idea. All right, this is 1.25, and this is 5/4, which if I change it, it's 1 1/4. 1/4 is 0.25, so they're exactly the same distance. Okay? And if I look at this last problem, it's 1/100th, and that's 1,000th. Sometimes it's easier to see it this way. If I had a pizza sliced up into 100 pieces, the two same size pizzas, one sliced into 100 pieces, one is sliced into 1,000 pieces. And I'm going to eat one of them. Which one's going to be smaller? It's going to be this one, okay? Okay? So it's just getting what's closer to 0. Now, here's what we are going to do in big letters on this page. And if you're taking notes on something, you need to write this down, okay? Absolute value is the distance from 0 okay? Now, what I want you to think about, can you go a negative distance? So I have my little I don't know if you can see him. Well, he's kind of ginormous for the screen, but that's okay. Here's my little kitty. He'd go frontward, he'd go backwards. But either way, if he went forward, let's say 3 steps, 1, 2, 3, okay, he'd end up here. If he was at the same problem and he went backwards 3 feet, 1, 2, 3, he's not going a negative distance. You can't go a negative distance, okay? So absolute value is always positive because distance is always positive, okay? Okay, because it's really important to know that distance is always positive. Okay, yes, I can walk backwards. Yes, I can run backwards, but I'm still going a distance. I can still measure how far I went. Okay, I can never go a negative distance. Now, these are called your absolute value bars. They're just 2 bars on the side of a number. So if I had 3, these are my absolute value bars. That tells me that I'm looking for the absolute value of the number. So what this is really asking me is what is the distance from 0 of 3? Okay? Instead of saying the absolute value, let's say what is the distance from 0? So I'm saying I'm 3 places from 0. So even if this was 0, 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. Okay, so if I say what is the absolute value of 3, I'm saying what is the distance of 3 from 0? I went 1, 2, 3. So the absolute value of 3 is 3. Okay? Now, on the other hand, if I have the absolute value of negative 3. Okay, get my absolute value bars. This means what is the distance from 0? Distance is my keyword, from 0. How many jumps would I have to make? If I started at 0, I would make 1 jump, 2 jump, 3 jumps to get here. So the absolute value of negative 3 is also 3, okay? It's not asking you for the opposite, so it's not asking you if this is negative, your absolute value is positive. That's not how it works. You're saying, what is the distance from 0 of 3? What is the distance from 0 of negative 3? So that's what absolute value means. Literally means the distance from 0, okay? That is the most important thing I want you to get out of this whole lesson, is that absolute value means the distance from 0, okay? That is the essence of this entire lesson. I was looking for a highlighter, but I can't find one. Okay, so we're going to move on. All right, so this one says, a flea, oops, let's get up here. Look at this straight. Okay, a flea is jumping around on a number line, okay? If the flea starts at 1 and jumps 4 units to the right, so he starts at 1, he jumps 4 units to the right. 1, 2, 3, 4. Okay. Where did he end up? Well, if this is 1, this would be 2, 3, 4, 5. Okay. He ended up at 5. He ended up right here at 5. How far from 0 is that? So this time I'm going to start at 0. It is 1, 2, 3, 4, 5. It is 5 places from 0. Okay, does that make sense? All right, so the second one says, if the flea starts at 1 and jumps 4 units to the left, where did it end up? Okay, well, it started at 1, again, and he jumped 4 units to the left. So he went 1, 2, 3, 4. Okay, so this would be -1, -2, -3. Where did he end up? He ended up at -3. It's not asking me for distance, just saying where did he end up? He ended up at 3, -3, I mean. Okay. My second question says, how far away from 0 is that? Well, I'm going to go to 0. How many places did I have to jump? I jumped once, twice, 3 times from 0. So that would be 3 places from 0. Okay, so this is what it's really asking you. What is the absolute value of the -3? It was 3 places from 0. Okay, so these were the same because we went positive, and distance is always positive, so they were both positive. This one we started at negative, and we were 3 places from 0, so those signs were different. All right, if the flea, I got to get a different color because I'm running out of colors. If the flea starts at 0 and jumps 3 units away, where might it land? So it starts at 0. It's not telling me whether I can go right or left. So it's saying, okay, well, let's say he didn't start. That's not 0, that's 1. He's starting at 0. So he could jump 3 this way, 1, 2, 3, and end up at 3. Or he could jump 3 in the opposite direction, 1, 2, 3, and he could end up at -3, okay? So he might end up at either 3 if he went to the right, or -3 if he went to the left, okay? How many places from 0 is it? 3. Doesn't matter whether I went right or left, he still jumped 3 times. All right. If the flea jumps 7 units and lands at 0, okay, where could he have started? So, same thing. He jumped 7 units, doesn't say right or left, where could he have started? So again, how far is 7 units here? So if this is 6 and this is 7, if he started here at 7 and jumped back to 0, he could have started at 7. Or let's say this is -3, -4, -5, -6, -7. He could have started here and went this way and jumped 7 places and ended up at 0. Okay, so he could have started at 7 or -7. Both are 7 places from 0. Okay. All right, so this is where we already did this part, but this is your definition. The absolute value of a number is the distance from 0. So that's what that's trying to show you, that even though it might be a positive or negative that he ends up at, it's how many times did he jump. All right, so it says the flea is currently to the left of 0 and the absolute value of its location is 4. What is the number, where on the number line is he? So it's saying that whatever the answer is, the absolute value of wherever the flea was equal to 4. There's only 2 numbers that I could put in here. I could say, well, the absolute value of 4 is equal to 4, and the absolute value of -4 is equal to 4, because the distance from +4 to 0 is 4. The distance from -4 to 0 is 4. This one said the flea is currently to the left of the number line. Okay, so he went left. That means this had to be -4. He started at -4. Okay. Number 5 is the same type of question. It says, if the flea is to the left of 0 and the absolute value is 5. Okay, so again, I'm saying an absolute value of some number is equal to 5. There's only 2 options. I could have the absolute value of 5 is equal to 5, or the absolute value of -5 is equal to 5. Because the distance from 5 to 0 is 5, the distance from -5 to 0 is also 5. He went left on the number line. This is 0. That means that this had to be -5. Okay? All right, and then G says that the flea is to the right of the 0 and the absolute value of its location is 2.5. So it's saying, okay, the absolute value of some number is equal to 2.5. Again, I have 2 choices to choose from. It is either 2.5, the absolute value of 2.5 is equal to 2.5, or the absolute value of -2.5. The distance from 0 of 2.5 is 2.5. The distance from 0 of negative 2.5 to 0 is still 2.5, okay? This one said he went to the right of the number line. So if this is 0, he went that way. So it had to have been positive, so it would be this one, okay? All right, so this says we use the notation the absolute value of negative 2. That's what those bars mean. Don't get that mixed up with a 1. It's the absolute value of negative 2 to say the absolute value of negative 2, which means the distance from negative 2 from 0 on a number line. So what does the absolute value of negative 7 mean? It means the distance from 0 from negative 7 to 0 on a number line. Okay, so we would say the absolute value of negative 7 is equal to a distance, which can't be negative, so it's positive. Okay, how far would you have to go to get to 0? Okay. All right, this one says, what does that absolute value of 1.8 mean, and what is its value? Kind of like we just did here. Again, it means the distance from 1.8 to 0 on a number line. Okay, so again, it's saying the distance is 1.8. So I'm saying, what is the absolute value of 1.8? It is 1.8 on a number line. This is 0, this is 1, this is 2. 1.8 would be about here. I'm saying, how far is it to get from here to here, okay? That's all absolute value is. A lot of people get mixed up and try to do the opposite. It's literally asking, what is the distance from 0? Just think that it's always positive, okay? All right, on this one, it says in the practice problems, just so we get a little bit more practice with this, is part of the city of New Orleans is 6 feet below part of the city of New Orleans is 6 feet, oh my goodness gracious, 6 feet below sea level. We can use -6 to describe its elevation. That means it's 6 feet down from sea level. And you can use the absolute value of -6 feet to describe the distance, okay? Not talking about how far down is it, it's saying what was the distance. So if I had to dive 6 feet under, how many feet would I have to dive, okay? So in the context of elevation, what would the following numbers mean? This would mean it's not an absolute value problem, so it just means you're 25 feet above, because it's positive, sea level. Okay? This means if I have the absolute value of 25 feet, okay, what does the following number? It means it is 25 feet from sea level. Not above, but from sea level. It means the distance was 25 feet, okay? Distance is always positive. All right. If we look at our negatives, if I say -8, that means it is 8 feet below sea level. So if I wanted to give somebody directions on something, if I said, like, here's sea level, and there's a cool coral thing, and I'm saying it's 8 feet below sea level, you'd go down to -8, okay? Now, if I say, what is the absolute value of -8, this means the distance is 8 feet from sea level. In other words, if I looked at this and I said, how far do you have to dive down to get to that thing? You would say you have to dive 8 feet, okay? So that's the difference. I know it sounds a little bit confusing, but if you always think, instead of saying absolute value, if you say what is the distance from 0, it makes it a lot easier. All right, the elevation number 2 says the elevation of city is different from sea level by 10 feet. Name the 2 elevations that the city could be, okay? So it's saying you have 2 cities, And it's different from sea level by 10 feet, okay? Name the two elevations. Well, if I say this is sea level, here's my sea level, half of it was down and half of it was up, okay? So it's saying from this top of this thing to the bottom of this thing is 10 feet. So I'm going to just divide it by 2. So I would say this could be 5 feet, or not or, and, A-N-D, that's an A, negative 5 feet. Okay? Because if I was at negative 5 feet, I'd go negative 4. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, the distance is 10. Alrighty? All right, the third one, almost done. We write negative 5 degrees Celsius to describe a temperature that's 5 degrees below freezing in Celsius. And 5 degrees Celsius for temperature that's 5 degrees above Celsius. In this context, what does each mean? Okay, this isn't asking for an absolute value. I'm not asking you how far from Celsius it is. I'm saying, what does this tell me? This means it is 1 degree above 0. I'm going to say 1 degree Celsius. I forgot my C. Above 0. Okay. I got a thermometer. Here's my 0. Here's my 1. Here's where my temperature was. It's 1 degree above 0. Okay. The second one, again, is not an absolute value problem. It's just saying it's negative 4 degrees. So that means negative 4, 1, 2, 3, 4 would be here. If this is 0 and this is a thermometer, this is 4 degrees Celsius below 0. All right, now letter C, not number C. Letter C says, what is the distance from 0, the absolute value from Celsius, okay? So it's saying that you're 12 units from 0, okay? That means the distance is 12 from 0. 12 degrees from 0, okay? Means I started at 0 and I went 12 degrees. This one, negative 7, means the distance from negative 7 to 0. From negative 7 degrees to 0 degrees, okay? This distance was 12 because no matter what, I went 12, right? This one would be, okay, I want a distance from negative 7, which would be down here. How much did I have to go to get to 0? I had to go 7. Okay, so my distance was 7. All right, number 4. Which temperature is colder, negative 6 degrees or 3 degrees? Well, negative 6 degrees because it's a negative. Okay, this is 3 degrees above freezing. This is 6 degrees below freezing. Which temperature is closer to freezing, negative 6 degrees or 3 degrees? Again, if you think about it, which is closer to 0? Here's 0. This would be 1, 2, 3, 4, 5, 6, need a longer line. This would be negative 6. 1, 2, 3. This would be positive 3. The distance from here to here is 3. The distance from here to here is 6. 3 degrees is closer to 0. So which temperature has a smaller absolute value? So absolute value of 3, we said was 3. The distance from 0 of 3 was 1, 2, 3. If I look at negative 6, the absolute value of negative 6 is, how many places did it take to get me from negative 6 to 0? 1, 2, 3, 4, 5, 6. Okay, which has a smaller absolute value? That guy does. Okay. All right. We're not going to do this one. We did enough absolute value today. And this is just your review page that helps you if you're having trouble. Just remember, your absolute value literally means distance from 0. This is the most important thing for this whole lesson, okay? Just telling you what the distance from 0 is. All right, I will talk to you guys soon. See ya, bye.